Hi everyone, I'm hoping this kind of works. Bartholomew or whoever is here, please let me know if my audio is actually working right, and so we can kind of go fix through that, and if there's any issue, just leave it in the comments and I'll try and fix it as quickly as possible. I'll keep my eye on the comments today. Yeah, what are we going to do today? So the intention today is to see if we can actually compute. Let's bring a window in this side. The intention today is to see if we can actually compute MFCC components from the audio that we had. The initial, so this is the steps. So you take the Fourier transform of the audio that you have. Happy day. I turned on my microphone. Yeah. By the way, Bartholomew's microphone worked, and it worked. That's cool. Yeah, it's a good day. So what we're working on today is we're going to try and compute some MFCC components, or extract the MFCC features of the audio of some audio, any audio right now. We're not very particularly concerned about what audio it is or whether the MFCC features is working or not. Thank you for the audio, for confirming that the audio works. What we're really concerned about is that we have an MFCC computation that works and that actually works for our use case. As we go deeper into this series, when we try and actually make this thing real, you will realize that a lot of changes will happen. We will need to move to smaller windows. We will need to move to some sort of like streaming and deadlining setup so that we can actually fit into the time deadlines that we have. But however, before we get there, we just need some working. I'd like to have a rough working sketch in, and then we can start building the application parts of it. Okay. Luckily for us, CMSIS DSP actually comes with features that allow us to do this. CMSIS DSP. Cool. I think it's here. CMSIS DSP. No, actually, no, that's not the one I want. I want this one. I like the new one. So CMSIS DSP here actually allows us to generate to actually get MFCC features out of some audio. And it looks as though we can just do this, and it can generate it can actually generate the MFCCs for us. However, there's quite a few things that one has to like pay attention to when we get to doing this thing. How do I say it? When we get to actually doing it, we will need some data that we don't have right now. We'll need like generate the filter and the DCT and the window arrays and all of those things. Actually, we might actually need it right now. This is a problem. We might actually need it. I was considering doing something where I just actually computed them just right out of the blue air, because really you can't compute them. You can't compute them. So this is what happens behind the scenes. What happens behind the scenes is you take the Fourier transform. We have a Fourier transform of a signal, and then you map this to the powers of the spectrum according to the Mel scale. And I've been saying Mel frequency septral. It's actually Kepstral. I didn't know that. Kepstral coefficients. Okay. So basically we start with an FFT of a signal, and then based on that we just keep transforming it until we have some MFCC features on the other end. I guess an MFCC feature is some sort of like filter that decimates some data, because you start with like 640 samples, and then you end up with like 10 features or something. And then you need to do this sort of like um, when you're traversing your data, you will have to do it in this sort of there's a way. So you want like overlapping windows, basically. You want overlapping windows because if you do it at the end, so let's actually just pull up this keyword thing. You want overlapping windows. Yeah. You see this? This is 640 samples, 640 samples, 640 samples. But each one of them is you just like you overlap 320 into the next one. And if you do not overlap like this, what happens is you will generate quite a lot of noise. And that noise is not going to help you when you're trying to identify things. And I think what I want to do today is to just make sure the function is working. And then once the function is working, we can kind of sort of go forward with that. Then we can go actually do some data science stuff in Python and actually take a phrase. I think we can take a phrase like Jarvis, and then once we take that phrase, we can actually come in and how do I say this? We can come in and we can generate that MFCCs for those feature, and then train a machine learning model with the MFCCs we've extracted. And then when we are extracting this, so in our app, whenever we are extracting this MFCC features, it's not for us to use, it's for us to hand over to some sort of machine learning model. And then this machine learning model will use those features that we give it to try and identify some sort of sound that we've given it before. And you can imagine if we're making some sort of wake word feature. And a wake word feature is something like, hey Siri. So basically, let's actually just try something. So I'll point my screen, my phone at the screen, and I'll go like, I can't see, but I'll go something like, hey Siri. And yeah, you see, she responded. The thing that happened there is there's some sort of like always on sensor or some sort of like low power system going on, and this low power system is really just waiting to hear that that phrase, hey Siri. If it hears that phrase, then it engages some other part of the system. What we're doing here is we are not actually preparing to do it. We're not training the phone to do it. That's a different thing. We have to train the electronics in the phone to actually do it. But what we're doing today is actually the using of it, the inference of it, where we speak and the thing actually identifies what we said, and then it triggers something else. That's what we're doing today. And then in another session, we'll sit down and we'll look at how to do it from scratch, where you kind of like extract these features as you go along. I might have to do something with zeros. I'm not so sure. I might have to do something with zeros and see if it actually works with zeros. I might have to do like placeholder numbers. What I'm aiming to do is to just hand over the signal, see that the signal actually generates some MFCC components, and then we can say MFCC is actually generating, and we put that to the side, and then we'll come back and we'll build this up later. It's often impossible to do all of these things at once in one sitting. So this is kind of what we're doing. Does anyone have any questions so far? Not yet. Okay, cool. Have a glass of water. So here's the other thing. It says the folder scripts contain a Python script which can be used to generate the filter, DCT, and window arrays, which is, I think I saw it, but I had difficulty running it. So actually, let's actually try and explore this thing that generates the thing for us. So it's cd dot, and then we cd the dots, and then we want to go into Zephyr, and then into Zephyr we want to go into modules, and then in modules we want to go into CMSIS. And then in here we want to go into CMSIS DSP, CMSIS, and then KMSIS, come on. I want to go into KMSIS DSP. Okay, cool. So let's look in here. That's odd. Okay. Maybe we just clone this thing and we see if we can actually do it. So it's fine. It's okay. Let's just go clone this guy and see if we can do it by ourselves. KMSIS DSP GitHub. Let's actually go clone this guy. Let's see. It would be nice if it can generate all the things that we need for us, and then I actually can just start with the real sample, and it usually can. Documents, and good clone. Let's do here. Yeah, let's do this. Let's actually get that and see. Any questions so far? What I'm trying to do is to try and find a way of giving it a WAV or a WAV or a MP3 file, and then it generates some, because you need these coefficients. You need these coefficients. You see these coefficients? You need this filter coefficient, and you need this DCT coefficient in order to perform an MFCC of a thing. So and it looks like the folder scripts contains a Python script which may be used to generate the filter DCT of the component. So let's see if we can get that working. I'm not a Python developer at all. I'm very bad at Python. I've really tried to learn it, but I can't really learn it, and that's been very painful for me. So we'll see how it goes. Yeah, CD KMSIS. So ls scripts. Is there a readme? Readme. Okay, cool. Yeah. Is this a long one? Do we go read it online? Is it easier to just read it online? Yeah. DSP kernels. Building for speed. Options to avoid. Hard float support. Building with CMake. Building for Neon and Arch64. That's okay. Code size file. Okay, that's okay. I don't want to build that. How to build. That's okay. I don't really need that. How to build on any other system, that's fine. How to build for Neon, that's okay. Code size, that's fine. What I want is the scripts folder. So scripts, debugging scripts, and scripts to generate some coefficient tables used by KMSIS DSP. Okay, cool. So let's see what is in scripts. Less scripts. So there is some stuff here. Generate data, generate MFCC data. Let's see. ls cd scripts. Yeah. ls MFCC templates. Okay. Cut mfcc.h data. RCD MFCC templates. Cut mfcc.data.h. Let's see. Yeah, this is fine. External console. It's okay. Is this what we're gonna use? Okay, cool. So I think we want to do cd dot dot, and then let's see, and I think let's try gen. This is like Python gen. Yeah, let's try it. It did nothing. Yeah, nothing changing here. But let's PyCache cut PyCache MFCC .pyc. Yeah. I just learned another one the other day. I just learned this one. I just learned strings. It did something. It just didn't do the thing I wanted it to do. Okay, cool. Let's actually see ls, and then let's make some make touch sample .wav, and then let's do the same thing we did, and sample .wav. Okay, let's see if we can get I think I have Audacity. No. Can I record stuff on VLC? Can I record stuff with VLC? Media, audio device. No. Video. That's good. That's okay. It's okay. I believe when I was preparing for this, I actually did download Audacity. Yeah. So let's see if we can actually get something working out of that. My poor little machine is boiling over, so sudo dpkg-i Audacity. No. Audacity. How do I install? Doesn't anyone know how to install an app image? Okay. See. Maybe that installs it, and then we see. Amazing! It's gonna install it. Cool. Accept and continue. It's over here. install it. I don't care. Continue. Nah, cancel. I don't really care about those ones. So that's good. That's cool. Okay, cool. So let's is this the installer? Can I close it? And then can I go like Audacity? Yes. Cool. It's fine. I do not know why that works like that, but that's okay. That's okay. So let's record something. Jarvis. Okay, and then stop recording. So this here is the data that we want. So what we want to do is let's just clean this up. Let's clean this up so that backspace. Cool. And then I want to come here and I want to go this way. Okay, cool. And then I want to do file export audio onto my computer. Export to computer. And I want to WAV, and then I want to dot, and then I want to say Jarvis.wav. Okay. And then actually we can just yeah, that's fine. And then that's actually all we want, so that's cool. No. Okay. See, and then I want to go back to the other thing, to the scripts. And then what I want to do is something here. Instead of this, actually, rather than that, let's do Python. Can I do that, Jen? And can I do sample like that? Okay. Ubuntu. I don't know Python. Running py script. Yeah, I have all of that. So yeah. Cool. Yeah, it's just the same thing I'm doing. Cool. So let's look at that. So yeah, it's the same thing I'm doing. So let's copy here, and then something like down documents, and then something like I think it's something like .wav. Where did we save that file? Recent. Oh my word, documents. Don't we have a WAV in here? Did we put it in downloads? Oh, this sucks. This absolutely sucks. Let's actually go redo it again. This sucks and I'm bad at it. That's okay. It's fine. That's fine. Is it in downloads? Yeah. Let's see. Let's do it again. Never hurts to do it again. Do it a million times until you understand it. Okay, cool. Let's go. Jarvis. Okay, let's stop that. We don't need that. We want to actually remove all of this. Where is it? We want to delete that, and then we want to go here. And highlight that and delete that. And then I want to play it so I can hear it. Okay, cool. So why is it not playing? Do I need to move this to the end? Do I need to move the cursor to the end? And Jarvis. It works. File. I want to export it. Export audio. and I want to export to my computer, and I actually don't want to do it there. I want to go to documents, and I want to go into engineering, and I want to go into DSP, and I want to go into scripts, so I have it there. And then I want to say this is Jarvis. I want to call it Jarvis. Save. Okay, all of these are a bit different. Are we sampling at 44? Yeah. Is it a signed, is it a, what? This is so hard. Anyways, later we'll get to this, because this has to match. I think it's 24 that, but this has to match. Right now, let's just do it. Let's just do the way we need to do. And then I can actually go here and actually ls, and if I have Jarvis, I do have Jarvis.wav, so let's just close this guy. Save project. No, I do not want. Okay, cool. And then ff play. This might kill the thing, but Jarvis. Cool. So that's fine. We have that. And then now we want to do something like this, but I don't want to use this really. I don't want to use this. I want to go Python 3. Okay, and then I want to quit. I do have that. I'll quit. Okay. My issue is not the MFCC. It's using Python. You would use something like Librosa or something to give you all of this information, where if you're doing it, and ideally if you're doing it. The kind of person I am, which is an embedded developer, would work with some sort of data analyst to help you with this. So, and they are very proficient at Python and such. And I'm not. I'm very bad with Python. So Python 3, and then we want to do MFCC data.py, and then we want to do Jarvis. And then let's see actually what happens here. I wonder if it just explodes. Something happened. So let's MFCC templates. Cut MFCC templates. MFCC data.c. No, that doesn't do anything. ls ls bycache. I don't think I need to go in there. That's some sort of binary. So what is happening here? What is happening here? City data git status should tell us something. No, there's nothing there. Okay, using the scripts is looking quite difficult. So how do I invrim? Let's try and read the Python itself so we see. What's in here? I'm quite defeated right now, so forgive me. Okay. Okay, please tell me how to use you. Please tell me how to use you. Okay. This all works. This all works. This all works. But how do I use this thing? How do I use this thing? Yes, this is exactly what we need. Generation of MFCC arrays for the C init function. This is exactly what we need. Targets on Cortex M and Cortex A cores. That's exactly what we need. But I don't see you running. I don't see you doing anything. Do I need to do to Q31? How do I pass in data? Can I do to F32? Yeah. So can we go like clear and then something like, yeah, okay. CD scripts. Who's good at Python? I need some help. I need some help. I do need some help. This is the funniest part. Look at this. Python scripts to generate C arrays using implementation for some algorithms. Fine, but it doesn't say how to use it. It does not say how to use it. I don't know how to use this. I want to go here. I want to go here. And I want to go like, doesn't say how to use it. Yeah. So maybe I need to just go into the issues and look. And actually what? Let's just do this. Let's just actually find out how to do it. It's fine. Let's go scripts. How are you doing this? How are you doing this? MFCC. Yes. Yes, I wish to see also the closed ones. Is that what I need to do? Do I need to run setup.py? For anyone who's joining us, I'm Zach, and I'm stuck using Python right now because I don't know how to use it. Okay. What do you do? What do you do? Let's do the thing every developer runs away from. How do you set up this thing? Yeah, that's cool. Yeah, that's okay. That's not what I want. I don't really exactly want to build it. I just want the Python wrapper to actually do some stuff for me. And it doesn't say how to use CMSIS DSP to generate MFCC coefficients. Doesn't actually tell me how to do it, so this is a problem. I probably need to know how to set it up. Yeah, but you don't tell me how to use it. Yes. Yes, fine. Yes, but I don't. Is there some Python script documentation somewhere? It doesn't even find. It doesn't even find this. That's funny. It never even finds this. So that's cool. That's cool. Usage and description. Let's look. Boom, boom, boom. KMC software library. Using the library. Examples. Introduction. Yes. Using the library. That's fine. Hey Nathan, how are you? It's been a while. No. So, look at this. There's this. Yeah. Do you see? Look here. So the folder scripts contains a Python script which can be used to generate the filter, the DCT, and window arrays. So I found this script. This script is this. This script is here. This is the MFCC. This is it's this MFCC PY to generate it. We can use it to generate our filters that we're going to use because sorry. Eventually, we need this. We need to point at our filter coefficients. We need to point at our DCT coefficients, and we need to point at our window coefficients. Now, in order to point at them, we have to generate them. We have to build them up. I don't want to do the math myself because I get sucked into rabbit holes like that, and then I lose like 4 weeks because I want to do it myself. There's ARM are really good people, and they've done it, so why not just ride on their shoulders? Okay. But I need to generate these, and in order to generate them, it's I don't know how to do it. I really don't know how to do it. I can just go like, perhaps I can do something like what is it? Yeah, Python 3, and then I can just remove it and see what happens. But I think that will explode. You see, and I get nothing new, so it didn't really work. And then I wonder if I can do -v, like dash verbose, for it to tail stop, but I don't know. So can I do like Python 3, gen something, gen neon, let's see. No module name tools. Do I need to do setup? Do I really need to do setup? Python 3 setup.py. Can I do that? Something's up. Somehow, I don't even have the thing on my machine properly. Somehow. So let's actually just go back and do setup by ourselves and see. I would have assumed Elixir. Elixir. That was live streams from 5 years ago. I would have assumed Zephyr would do it for me, but I don't see it doing so. So let's actually see if we can get set up. Yeah. Table of contents. How to build with Make, with CMake, with any other build system. I don't need to build it. Do I need to build this thing? Is this the toolbox it's referring to? I'm stuck, guys. I'm stuck. I'm really wanting to not be stuck. I'm very stuck right now. It doesn't, yeah, I have that. I'm trying to run that. Do I need to commode that? Do I need to chmode that? Set up. Same thing. Actually, let's do that. Let's see. So what do you want? What do you want? What are you gonna tell me? How do I use you? So you want me to say build? Build? Is that one? Everything's just exploding. It doesn't want me to do that. And I'm staring straight into the sun. Summer is finally coming here, and it's gonna be insane. It's gonna be warm this year, I think. Summer's finally coming, and it's gonna be warm. Let's see. We'll build the package underneath build. But there's nothing in build. Oh, I know. It'll build everything inside build. Okay, cool. Okay, whatever. Cool. But it just fails. We can't do a dry run and see. Dry dash run. There's a different way of doing this. We can use Librosa. But Librosa doesn't give us any coefficients. It's only gonna give us MFCCs, which is not what we want. Our code will give us MFCCs, but I don't know that Librosa will generate all the coefficients we want. So we can do this. Generate MFCC DCT coefficients. I wish Barnard was here. Barnard will help me. Barnard would teach me how to do this really good. So here, look at this. So here, look at this. Same thing is going on there. So here, look at this. So this would actually, you can run it as such, but this would just go straight to giving you MFCCs. Wait, let's see. Librosa feature spectral feature MFCC is Librosa features at MFCC. That's fine. So that's not what we want. Chroma, CQTs, VQTs, MEL spectrogram. No, that's not what we want. So, no, that's not what we want. Feature MFC. Yeah, cool. Yeah, no. DCT type equals. Why not? SR is that is sampling rate. S, I don't know what an S is. Low power of that, that's okay. MFCC 20, number of MFCCs to return, cool. Discrete cosine transform type, by default type 2 is used. Yeah, you see, where these types, because this is a type I need these. I need these types, and I don't have them. This is where I need someone from data science to help me. And I probably need to go and find someone who can help me with data science stuff, because then I'd be able to actually get those MFCCs. It's not, the MFCC is available, we just don't know how to do it. That's probably the issue. And I don't know where to find it, because I need to find this DCT coefficients, this one's DCT type, not even those. So not the type itself, but the coefficients themselves, because those are going to be the ones that we use. Let's see. Let's see. Shall we just give it a bash? Let's just try it and see what happens, and then we can stop at that, and then we know we need someone to help with that, and I can go find someone to help me, and then we'll on the next one we'll be able to do it. Yeah, let's just give it a bash. It won't work. It's gonna crash. I already know. I already know it's gonna crash. Why do I know it's gonna crash? Because why is it gonna crash? It's gonna crash because this is missing. So let's look at parameters. What does in out mean? Number of MEL filters, cool. Number of DCT outputs, cool. Points to an array of DCT coefficients, we don't have that. Points of the array of filter, points to the array. Points to the array of filter positions. Okay. Points to the array of filter lengths. Points to the array of, okay. I'm just gonna try it. Let's just, I don't see how, because it says here, the folder script is containing a Python script which can be used to generate the filter, DCT, and window arrays. Let's just generate stuff. Let's generate stuff and then we'll see. We need to do some math here. We need to do some math. So we actually just want to follow this. We actually just want to follow this, and what I want to see is here. Can I go back? Yeah. So what we want to follow is this, and what we want to do is, in total there's 49 windows, each having 10 MFCC features. So in total we have 49 times 10, 490 10 MFCC features. But that doesn't tell us the exact story. We're going to make 490 out of a sample size of 16,000. What's a third of that? So it's going to be something like what's a third of that? So that's 4096 times 3. Yeah, that's okay. Cool. So if we get from that, we'll get 490, something like some sort of I think 490, but we just need a third of that. 490 we need 163 features. We need 100, and eventually we don't want to do it like this. What we want to end up doing is we want to do it in very small slivers. So we want to do it at like 640 samples, not like 4096 samples. But for now, we just want the calculation to work, and then we can move on from there. Excuse me. Can I have a sip of tea? Okay. Let's see. Let me think. How do you want to do this? Do you want to scale down and just see that it calculates? Or do we not? Let's actually also look at something else we've used, and maybe we can understand it from the thing that we've actually used already. So instead of looking at this, let's actually look at the real FFT transforms, and let's look at the F32 one that we've just done, and then let's look at this one, ARM fast F32. So this is in, points to that, in, points on input buffer, in, points on output buffer, in, points to that. What does in mean? What does in mean? What does in mean? And why is there an out on the other side? What is it? It does mean something. It does mean something. So, and then in MFCC F32, when we look at we can look at any one of them, but let's look at this. This is init. So this returns this, but you need to pass in that. 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 Let's attempt it. Let's attempt it. I expect we'll get an error. Let's just attempt just to initialize this. So let's actually go into our code for the first time in this 10 minutes to the end of the session. I think that's quit, something like that here, and then I can do something like nvim that, and then in here, we're all good. So let's just go pf, and then we're gonna go into inference service to see, and then in here, what we want to do is we want to come down here, and once we've done this initialization, all of it, we are good. We should be fine. But let's actually now just look at, we want to do some sort of initialization here. And we need quite a bit of information before we can do the initialization. So let's leave this here, and then we can go this, and then we can do something like filter variables. And then here we can go like and filter. And filter variables, because we're gonna define a large bunch of these variables. Okay, cool. Let me just make sure everything is working fine, and we are actually streaming, and no one is lost. Okay, cool. So let's do that, and then let's down here. Let's actually define a few more things. So MFCC variables, and then in here let's do an end to that. So end MFCC variables, so that we know what we're doing, and we can always come back and remove blocks of our code as we deem fit. So out, we don't need. These we do. Number of MEL filters we can actually decide later. Number of DCT outputs we can also decide later. So we can provide this later. What I want to do is this one's, okay? Points to an array of DCT coefficients. So let's actually just do 10, you know? Yeah. And what are they? DCT coefficients? They are float 32s. So there's a float 32s. And I expect, I have a float 32. So here, and I expect it's something like this. Let's actually do that. Let's actually do that. And I shouldn't use my mouse, but I will. Let's actually rename this, and then I'll go like let's make some arbitrary numbers so that we can actually just stay there and see what happens in case we actually can't do that. This is a magic number that I'm introducing, but we'll figure it out. Okay, we'll figure it out. So here, what we want to do is we want to name them a few things. So we want 3. Actually, we just want 3. Yeah, that's okay. So we want DCT coefficients. So DCT coefs. Okay. And then we want filter coefs. Filter coefs. This might break everything, and don't worry about it. It'll all go okay. It's fine in the end. Window coefs. Okay, cool. So we have this defined, and we can actually go as far as saying MFCC uint 32d or int MFCC num, MFCC num, and then we can actually call it 10, and you know we can do something like define. Is that it? Is that it? Can you do that? Can you do a define like that? Is that valid? Is this valid C? I'll remove this and I'll give it a type. Actually, I have to give it a type, and I have to do something like hash define probably, and then yeah, that's okay. That's okay for now. So let's leave it at that, and then we'll get back to it later. So, and then in here, what we want to do is we actually want to instantiate this, and then we can see if it actually works out. So we want to go rm status, and then we want to go MFCC s instance is equal to rm we want something like MFCC, yeah, and then we want something like init, and then we intend to do 4096, and then we intend to do F32, and then we want to go here, and what we want to do is make an instance rm MFCC MFCC, what do we call it? MFCC F32. It's an MFCC F32. And then in here we want to go MFCC inst. Okay. So we'll look at the flag just now, F32, and then in here we'll take it. It'll take the MFCC inst. Something like that. Does that fix it? Yeah, I did do that. Where is it? Where do I need to insert that? Nah, you just don't know what you're doing. Stop it. Why are you doing that to me? Let me see. Instance F32. Okay, cool. So okay, cool. Instance. Instance F32. Okay, cool. That actually works. Okay, cool. And then in here we want to do MFCC inst. Okay, cool. And then now we want to start doing the other stuff. So this takes, the init takes, first of all, number of mel filters, and then we know this is like, we can actually go to the next line. And then I want to do MFCC num. And then after that, what do I want? I want MFCC, MFCC num, MFCC num. This is gonna explode in spectacular ways, and then in here I want DCT, okay, and then the next one I want filter pause. So this is going to be what? Filter positions, what? Points to what? Filter points to an array, points to an array of filter positions. It's just uint32s. Okay. uint32 t filter pause. We'll rename this please just allow me to do some experimentation. Filter pause and then filter length. uint32 t filter length. I expect it will. I fully expected it to crash. It would be very weird if it doesn't crash. So that's this. But sometimes you have to do stuff even if it will crash, just to see why it crashes. Filter pause. Okay, after filter pause, we want filter length. Okay, after filter lengths, we want filter coefficients. Filter coefficient. And then after filter coefficients, we want window coefficients. And I want to do that. And then I want to do log warn MFCC init status equals to let's do a D, and then we can go there, and then we can actually be like, this is going to be MFCCS. Can we do that? Yeah, I don't want that. I want this. Can we do that? Is that workable? Okay, let's build this. Let's build it, and then we can kind of finish the stream on like we're stuck again. West build dash B and a ref 52840 dongle and a ref 52840 dash pristine. It might even not build. Might not even build because, but we did enable transform, so it should be okay. Should be okay. Any questions so far? I have more questions than you guys probably, because I don't know why do they give me a script if it doesn't work, and I don't want to use Librosa because I don't want to go away. So the thing that happens with machine learning is if you train your model with like data generated by this, and then you go and try and consume it with data generated by that, the disparities are so much that it doesn't work. Like if you use Bartholomew's microphone to train your model, and then you try and use my microphone to do inference, it might not work, or it might work in very unexpected ways, because both of these things is just changing everything. The sensor realization of this sensor and the sensor realization of Bartholomew's sensor, they're just different enough that it would give you different data on both runs. So you don't want to mix and match these things. So I don't want to go and generate all my questions using Librosa and then come and train my model using TensorFlow and then use KMSIS, and if you do that, that's a mistake I made the last time I did this with a group, and we ended up like spending months, and the thing was not working. And what we ended up discovering was you have to use the same set all through. And the reason I've struggled so much today is to try and figure out how I can do all of this within KMSIS, because what you usually would do is you use MFCC to collect the fast. You use KMSIS and you collect the fast MFCC features out of your data, and then you take those MFCC features. You actually have to train quite a lot of stuff. You take those MFCC features and you go and train a model based on that. And then once you train a model based on that, you quantize that model, you minimize that model, and then you come and you run it on your embedded thing. And then in your embedded machine, once you're running that model, you sense the audio coming in, you generate the MFCC features, and then you pass these MFCC features that you've generated from the incoming audio into your model, into your TensorFlow Lite model. And then once you do that, the model can then decide whether the thing you want to recognize is there or not. You see? So it's a whole family of things that needs to happen. Let's see if we can park this. HW. Let's park it. It's gonna be ft.zip, and then I'm gonna power this up and do bootloader mode. And I fully expect this to crash. If it doesn't crash, then I'm uninformed. Which is actually the best things, because your code works. You just didn't know it works. Huh? Never been worse. Never been worse. So actually, let's come here. Let's go here, and then Control R, and then we can find the screen, and then that. Okay, Control R screen, and then we actually want SEM0. SEM0, and I'm gonna I think it's done, but I think we were too late, so I'm gonna disconnect it and then connect it and then try and run this. We should get our usual thing. Cool. So now I'm gonna connect to it and see if something happens over here. I fully expect it to crash or something of the sort. Oh, come on. I want a case sleep. I want a case sleep a bit. So here, let's actually do a case sleep. Case sleep. And then what we want to do is a case sleep of like something like KMSEC, and then we want to do like 500, half a second. So that way we get to like actually see the stuff. And this doesn't work because even if we disconnect, it doesn't actually do the thing we want it to do. So it's not working. It's not working the way it's supposed to. So, anyways, we'll fix that later. Well, thank you so much for the people who came to the stream today and watching me struggle. This is it's quite strange. In some ways, it's very encouraging because I know I have a community that I can fall back to, so it's cool. Yeah, it's not as cool as flashy as other streams where everything just works fast go. Those people are really good. My stuff rarely works fast go. Actually, it usually takes weeks before it works out. So it's good. Is it kind of normal development works? I think so. I do think so. I do think this is kind of how normal development works. Well, I don't know. All I know about development is what I experienced myself. So I'm gonna check some messages while that's building. I don't see messages right now, so that's good. That is cool. That is cool. It's still building. It's still building. Sorry about that. I just wanted to pause on that for a bit and then we see whether the thing actually generates before we finish the thing. So I just wanted to pause on that line so that we see the status of that actual filter. I'll be very shocked if it's successful, and even if it's successful, it is so random, it's not going to work. So we need some data science help, and we'll get it. Don't worry about it. I have a lot of friends who do data science. Usually, this is what happens. Usually, someone just gives me this data, and then I go use it. Here's your coefficient. Here's your thing. Here's how many needs to come out, and then I go use it. But that's not the case right now. So let's go. So let's park it. Cool. And I put this guy in bootloader mode. And then I'm gonna flash. That's okay. And then I'm gonna come here and make this command ready so that once it's done, I can just click there and like hit enter, and I won't miss that much. 1, 2, 3, done. Enter. Shit. 1, 2, 3. Give me something cool. Let's actually look at it. It should give us some sort of thing. It's gonna be fast probably. Come on. Ah, my word. I know what I need to do. So let's actually remove that. Try again. Never give up. Never give up, never give in. Yeah. I don't know which song that is. It's gonna work. Life's hard, man. Life is hard. And at the same time, it's extremely easy, man. Life is hard and extremely easy. Both of them at the same time. There's so many things. So there's that audio project that I posted on the group. I don't know how many have seen it, but I would be very keen to get a little team together so that we can work on that together. And I'm gonna spill the beans on the stream actually. The audio project that we are working that I posted on the group, the thing about Zephyr missing an audio stack. It's actually quite interesting because Zephyr doesn't have an audio stack. So whenever you do stuff with audio, you don't have the proper timings. You can't like just, you can't just call out to audio and then use the audio drivers for that. And the thing about that is NXP is trying to become a multimedia provider. So they're trying to build up a lot of audio and video capabilities. And so Nordic is trying to... Yeah, I believe you, Bartholomew. So, and Nordic is trying to... what is Nordic trying to do? Nordic is also trying to sell a low energy or BLE audio. And if we have BLE audio, they still need an audio framework, you see? And the way open source works is all of these big companies you've heard of, they're not huge, they're not anything. What they actually want to do is build hardware. They don't want to build software because other people will build software for it. So there is a big opportunity right now for someone to come in and build an audio subsystem on Zephyr and actually make money out of it, make contacts out of it, probably even get some payment from NXP and NRF and all of those people. But it needs someone to actually take some stuff and do it. And I intend to do it. It's just life. Not life. I just haven't gotten myself settled enough to do the thing. But I will. So I'm very interested in joining up with a few people and building out the audio subsystem in Zephyr so that we can actually experiment with it. Cool. Let's see. Hopefully it stops there for a bit, and then that actually helps us. Connect. Did it actually do it? Control A. Okay. I want to scroll back up. How do I make it? How do I make it stop? Let's actually give it. Let's do a crazy one. So let's do KMSIS. Let's wait 5,000 so that we actually don't do half a second. So then we'll go again. Sorry about this. It seems as though it's working. So that's actually. Let me see. It came up on my screen the stream right now. Listen. Wait. Doesn't it set up before the thing? Doesn't it set up before you're ever allowed to run? Did we even need to? It accepted it. Computers are crazy. Imagine garbage out. Computers are crazy. So it works. Anyways. So it does work actually. It accepts the thing, but we know it's gonna generate garbage because the thing we gave it is not really real. So anyways, thank you everyone so much for coming in today. This was a really cool one. What I'm going to do now is I'm going to join hands with the machine learning person at work, and I thought this would be easy. I really thought it would be easier because I read up and I saw how to do it, and I thought I would get a script and the script would give me everything and I could just plug it in from here forwards. I know what to do, but I know that the steps that I've taken to get here are really wrong, so it wouldn't even work even if we tried to do it. It's gonna be wrong anyway. So I'm not interested in doing wrong things. I'm interested in doing real things. And like Bartholomew says, every defeat brings you closer to victory. So it's fine. This has defeated us, but we're going to redo this. I'm going to work with someone who can do machine learning, the Python stuff, and they're going to give me the right coefficients. And I'm going to come back and then we're going to redo them on our machine. And then from there on, we'll have the right machine thing and we can get someone training. Maybe I'll even get someone to do, let me see. Maybe I can get someone to do the training while I do the embedded stuff for this. Thank you so much for everyone for showing up to this stream. I'll see you guys tomorrow. It will be better. We'll learn some stuff and we'll have some answers. And thank you. Cheers. See you so much. Thank you. See you again soon. Not see you so much. Anyways, whatever. I'm weird. I'm a human just like you. Cheers. See you guys. Thank you.